Okay, so hello everyone. Today we'll have a webinar about the basic things about how to create an API using Spring Boot and what other tools we need in order to create such an API. So first off, let's start with what is an API. Basically, an API helps us connect the front end, so the client, with the database. So it is basically some sort of a middleman between our front end and our database, which also parses the data in ways that we want. So for example, we can create some computations or something with the data that we receive from the front end, or we can compute some data that we retrieve from the database and then return it to the client. You have the definitions on the left. I won't read those from the slides for you because you will have the slides later and you can read them if you want. So I've told you the brief definition of what an API is about. So basically, it's just an interface for your database, which ensures data validity and so on. Okay, so here on the left we have kind of the same diagram as this one that is on the right. We have the front end, we have the API calls, which can be of multiple types, but the most used ones are get, put, post, and delete. Then we have our backend with which the front end interacts. So your API calls will be from the front end to the backend, and then the backend will query the database for the data that we want to have or we want to save, and so on. So today we'll study the backend part. In the last webinar with my colleague Alex, you've studied the Android frontend, and now we'll see how we can create our own API and perform those queries on the database and so on. Those API calls usually contain a body, which is in the form of a JSON file, or it's a JSON. And a few years ago it was an XML, but it has been decided that a JSON is more effective, so and smaller in size. So we are using JSONs now. And for the scope of this webinar, will also use JSON, so it will be a brief demo of a real-life API, and we'll see how to code that later. Okay, usually GET requests will be used to retrieve data. So for example, if you want to retrieve something like an object from the database, you use a GET request. If you want to update some fields of an object or so on, you'll use a put request. If you want to create an object, you use a post, and if you want to delete, of course, you'll use delete. You can also, if you want, you can delete using the GET request. Those are just conventions, but you should respect them and use delete for deletion and the other ones for their own scope. Okay. By the way, if you have any questions, you can stop me at any time. You don't have to raise your hand. You just unmute yourself and can ask the question. Okay, so what other elements besides the programming languages do we need in order to build an API? So I've told you about JSON. JSON is JavaScript object notation, and we will use it to pass data around from our front end to our backend. And it will be, our object will be serialized and deserialized from and into JSON. So it is an industry standard, so to say. It's used in almost all the API calls except for RPC ones. If you have something custom that you want to be even faster, you'll serialize the objects in another way, but that's not the scope of this webinar. Okay, so this is how a JSON looks like. You'll have your keys on the left. So in this case, username and password, and their values on the right, which in this case are my username and my passwords, the things in blue. So if you know Java and you've seen Java objects, the keys in this JSON are actually the variables that are in your class. So for example, if you had a user class here, it would have had a string username, string password, and that's it. You can also have arrays in JSON, which are represented with square brackets, and we'll see how a JSON containing an array will look like when we test the simple API that we'll build a little bit later. Okay, we will also use Spring Boot, which is a framework that helps us build RESTful APIs. The other option would have been Nest, but I chose to show Spring today because I've seen that a few of you on the group said that used Nest, so I thought that this should be a fresh thing for everyone. Of course, you can use any other framework you like to build your backend. But Spring Boot is, an enterprise-grade framework, and it might prove useful for your career later on. Okay, besides Spring Boot, we'll have Docker, which is a container platform. Docker is also used in production, but it's mainly used for this tutorial. We'll mainly use it in order to have our SQL server, such that I don't have to install it on my, on my laptop. I just create a container with that SQL server, and I can connect to it from my Spring Boot backend. So basically, it acts like a small VM, if you know what a VM is, but it's a more lightweight one. So it just has a very thin operating system on top of which we have the software that we want to use. So in this case, it's just a small Linux distro on top of which we have the SQL server. And in order to test our API, because we don't have a front end, we can use Postman, which is a tool that is specialized for such tasks, or we can also use Swagger, which will automatically build a page of that will contain a list of the endpoints that I have built in my Spring Boot backend. Swagger or OpenAPI, they also work on other backend frameworks, so you might have heard them or used them before. Okay, so now let's have a quick demo on how to build an API in Spring Boot. If you have any questions so far, is everything okay? Do you want me to go like a bit slower or faster? Okay, then I guess it's fine. Good. So this is how Postman looks like. We have this URL thing here. This is the URL at which we can access our API. We have the type of request on the left. So we have get, post, put, delete, and the other options, but those are less used, so we won't talk about them today. Okay, and I have already started my Docker with the SQL container. So I have the SQL container here. I can click on it and see its output in the terminal if I want to do something like that. Okay, so in order to create a Spring Boot project, you can go into IntelliJ and click on New Project, and then select on the left Spring Initializer. So it's here. Then you'll enter your path that you want to use, your project name, your package name, and then you'll click Next and select what dependencies you want. You can also use start.spring.io, which is in the browser, and that will download you an archive which will contain your project. So you can select what dependencies you want here and what build tool you want to use. Okay, we can use Spring with Java, Kotlin, or Groovy. I will use with Java today, and we can have multiple build systems. So does anyone know what a build system is? Okay, so I guess not. We have multiple types of build systems: Gradle, Maven, Ant, and so on. Those basically help us contain or build our application, with a tap of a button. So they will hold whatever commands we have to. We would have had to type in the console, and they do that for us. They also handle the dependencies, such as their versioning and pulling them from the cloud and so on. Okay, for today's project, we will use a few simple things like SQL, and we have here MySQL driver. So this is the one that we want. You also want the Spring Data JPA in order to be able to map our objects to queries in the database. And we will also use Spring Web such that we have the REST annotations. I have already pulled the project, or created this before. You can also have this project on GitHub. I'll put the link on WhatsApp, so on the WhatsApp group, because I think you can't see the meetings chat. Okay, so I've posted the link on WhatsApp in the README of the repository. So if we take a look at the repo real quick, we can see, so this is just a demo. It will be a really simple API. We just create an object and retrieve it, and that's quite it. In the previous years, so in the first run, so to say, of the Hardcore Entrepreneur Hackathon, we have built a simple login API. If you click on this link, you will have the GitHub project for that. And in the second year, we built a demo API for a news website, which was a bit more complex than today's demo. But I have decided that it would be easier for you to understand if we make a simpler API. But if you want to look at something more complex, you can take a look at those repos and see, how a full, so to say, API can be built. Okay, so the main structure of a Spring application has a model, service, controller, and a repository. So I will build those packages now. So let's cd into the demo project, and we can see here that those are all the folders that we have. So I'm interested in source, then main Java, and let's. Okay, so now I'm in this file tree, so to say. So if I take a look, I have the demo application.java, and now I will create my packages. You can also double click on this or right click and new, then package, but it's faster for me to create them from the terminal. So I will make my model, my service, my controller, and my repository. And I will see them on the left here. Usually those won't be in plural, so you won't have controllers or models or repositories or services. You will have them controller, model, repository, service. Okay. So let's start with the repository. So if you've seen on the slides, we had the database, then we had the backend, and then we had the front end. So I will start with the repository, moving from the right to the left. So right is the database. The repository will interact with the database. So I will have a toy repository because our API will handle toys. Okay, and this repository is an interface, is not a class, because the magic of the Spring's ORM, ORM is object relational mapping. This repository will contain some functions, some basic functions that will help me handle data or passing data from and to the database, in a quite simple manner. So I won't have to write the tedious SQL queries. I can also write them if I want some custom things, but for tutorials, for today's demo, or for any medium to simple API, you could rely on those and have absolutely no problem. So let's extend JPA repository. And here I will have to specify what type of things I want my repository to hold. So for example, this being a toy API, I will hold some toys in my database. So I will have toy, which is the object, the model that I will create later. And then I'll have a long. The second thing, this long, is the key of the object. So in the database, you have your models field. So this toy, if it will have a color or so on, it will in the database I will have some columns with color, description, title, and so on, and I will also have a key, which in this case is a long variable. Okay, and that's everything that I have to write in the repository. Because as I've said, I will have some functions already created for me, such as retrieving a toy, saving a toy, and so on. So now I can proceed with creating the model. So I will create my typical Java class, which is in this case a toy, and I will have to annotate it with some things. So in order to tell Spring that I want to save this toy in the database, I will have to annotate it with entity. This just says, hey, this object will be held in the database. You can see the icon on the left. This is also a visual representation that this object will be held in the database. I will also have some Lombok annotations. So if you've written Java, you've seen that if you want to have a class with some private fields, you'll have to write getters and setters, constructors, and so on. If I have Lombok in my project, this will help me automatically create the getters and setters and all the constructors at build time. So I don't have to actually write them. So if I put this data annotation, I will have all the getters, all the setters, and the constructor for the values that I add here. I will also use the builder pattern because it's a bit nicer compared to just instantiating an object using the normal constructors. This basically just helps me build the object step by step. So if I have a name, description, and an image, I will be able to build the toy first with a name, then with a description, then with an image. We will see how that works a bit later. If I have the builder pattern, I also have to specify args constructors and args constructors. And I think that's all that I need. Okay, you can see that this toy object is now red and it tells me persistent entity toy should have a primary key. So I've told you earlier about the keys that objects must have in the database. Let's also import this here. So it's of type long. So I will just have private long ID. This guy still has an issue with me because I need to specify, or I need to tell Spring, hey, this variable will actually be the ID of my object. So I need to annotate it with ID. And to make my life a little bit easier, I will also annotate this with a generated value because I want this to be generated automatically by the database. And I will say that the strategy for this generation is generation type auto. Okay. And now I can go on with the usual fields that my object has. So for this demo, let's say we'll have a name, a description, and an image. So I have private string name, private string description, and my image. Okay, so now my object is done and I can store it in the database without any issues. So using this repository, I will be able to call the functions that will create the queries for me. Okay, so we can have we can interact with the repository directly from the controller. But it is recommended in the case of more complex APIs to have a service instead of doing all the things in the controller. So usually in the controller you will validate the data. So when someone wants to save a toy, for example, in the controller I should validate the toy that that guy wants to save using my API to have a valid name, a valid description, and so on, or whatever other fields you have in your model. So, and then I will pass that data to the service, which will interact with the repository and actually save the toy object in my database. Okay, so let's create the service first, which will be a bit lengthier than the repository and the toy. So we have a normal Java class. I will name it toy service. You can see the naming conventions here. For a service, I will have the name of the thing that I want to use the service for. So in this case, a toy, and then I will have service. For the repository, I have toy and then repository. For the controller, I will have toy controller. Okay, so I need to tell Spring that this is a service. So I will annotate this with the service annotation. And I will also use a required args constructor because I want to inject my repository in this service. So Spring, is centered around the dependency injection, which actually helps me, quite easily change databases and so on. So I can just have private final toy repository and name it toy repository like this. So this will everything that this coupled with this will do is just have one instance of the toy repository in my toy service. And our API will be able to handle saving a toy, creating a toy, updating a toy, deleting a toy, and getting all the toys that the database holds. So I will have public toy save toy. Let's import the toy model. And I will receive, let's actually start with get toy. And I will receive a long ID, which is the toys ID. And I can return toy repository, find by ID, and pass the ID. And then I will use or else throw, or okay, so I'll just call it get. Also, the issue was find by ID instead of find all, and okay, so if we take a look at the repository, we can see that we don't have any function implemented in it. So I'm calling a find by ID on it, which we can see that exists because it's not read here. And we can see that this find by ID is implemented in CRUD repository. If I take a look in my repository, I can see that I have a JPA repository, which is fine because JPA extends itself the CRUD repository, so I will inherit those functions. So this is basically everything that I need to do in order to save the toy to the database, or to retrieve the toy from the database. I just call find by ID, I pass the ID of the toy, and everything that this or else throw does is, if this find by ID doesn't find the toy in the database, because we can have this problem if I have in my database the list of toys and they don't have the ID that I'm searching for, well, I need to do something with that. I can just return a null. So I will throw an exception. I won't write the throwing of exception part because it's not relevant for this part of the tutorial. Okay. So do you have any questions so far? Okay, then I'll move on with creating the other functions. So I will create the create toy function, which basically just adds the toy to the database. So I'll have public toy because I will also return the toy to the API caller after I create it in the database, because I will populate the ID field of the toy with a value that you can see it's automatically generated here. So when someone wants to create a toy, it will just take the next ID available in the database and it will save it in it. So I have the name, description, and image provided from the API caller, but another ID. So I will return that ID in the form of the entire object to the API caller because maybe he wants to use it for something else later on. So I will name this create toy, which will receive a toy object because I need to save all the fields of the object to the database, and I will return toy repository, save, and then the toy. And that's it. That's how I can create a toy object in my database. Let's take a look at how we can update an object in the database. We can have two forms of updates for an object's fields. We can update the field like specifically that field, or we can just override the entire object in the database. So in this case, I will override the entire object because it's easier. So I have update toy, which is similar to the create toy thing, but instead of creating a new object, this will just update the fields of the object for the ID that I have specified here. And let's also have our delete function. So this will be a void because I could return a bool, but let's just say that the delete will actually happen when I call the delete function, and I will have a void delete toy, and I will need to have the toy's ID. I don't need the entire object, so long ID, and then I can just do toy repository delete, and then the ID. It's delete by ID, I think, yes. Okay. For save and delete by ID, I also have those functions implemented in the CRUD repository, so I don't have to worry about implementing them in my toy service, in my toy repository, which I have here. So this is empty. This is just an interface that I need to create in order to have those functions available. And let's just retrieve the entire list of toys from the database. So I have a public list toy, which will be called get all toys. I don't need any parameters to receive, and I will just return toy repository and then find all, which will return the entire list of toys that I have saved in the database. This is a bad practice because when you have an enterprise application, or if you have a lot of users, if you do a find all, this will be very bad for your database, because retrieving a lot of objects or millions of objects will take a lot of resources. So usually you'll want to filter those objects using a query and not retrieving all of them, or retrieving all of them and then filtering them here with a stream and then a filter. That will also be bad. You need to filter them using a query such that your database returns the minimal amount of objects. Okay, so I have all of those functions created. What do I have to do now? I just have to create my controller such that someone from the exterior can interact with my logic. So you've seen on this in Postman that you have this URL. And what does this say? Basically, if you insert this in your browser, for my backend, which will start at this location, which is also equivalent with the domain name. So if you enter on a website, instead of this, you will have your domain name. So upp.ro, you'll have this here instead of this, but we'll run this locally. So that's why I have this local host and then the port number, sorry. Okay, and after that we have the path. So I will want to have my all of my toy logic in a /toy and then with different names. So I will create my controller, which is a Java class, and I will name it toy controller. I will have to annotate it with REST controller because this is a REST controller, a REST API. I don't want to return, some HTML if I would have wanted to return some HTML, I would have had the normal controller annotation, which is controller. But I want to have an API that returns JSONs and objects, so I will have REST controller. Then I will also have my mapping, which basically tells me where to find, or tells the backend, if the user enters this path, then do this function. So I will have the request mapping, which in this case I would like to be API/version1/toy. And similar for the thing that we had in the service, I have this required args constructor, which I will also use here. But instead of having the toy repository, similar to what I've had here, I will have a similar thing, but for the service, because I have my functions implemented in the service. So I have private final toy service, toy service. So now I can call those functions from the service in the controller. Good. So a question that you might have is, well, we only have one line of code here. Why don't we just use the toy repository in the toy controller, and that's it? If you remember a few minutes ago, I've told you that if you have a more complex API, you will have to, validate your data in the controller and then pass everything to the service, which will compute some other things. So for example, if you have an application that, for example, stores some data for drivers, you will validate the data here. So make sure that everything is fine. The doubles are actually doubles, the strings are strings, and they have the appropriate length. Then you will parse them in the service. So you will, compute, I don't know, the number of kilometers and so on. And then you will use the repository to save it, to save the computed data in the database. So that will be the flow of data in your application for the example that I've said earlier. Okay, on the slides, we've seen that we have 4 main types of requests, and I will demo all of them for you. So we had a GET request. So all I have to do in order to handle a GET request, I just have to annotate the function that I will write below, get mapping. I will, this will be the function that will retrieve my toy from the database using the ID. So I will need an ID here, which the user of the API will provide me with. So public toy, get toy. Let's also import the toy object. So now I just have to return the toy object, and I'll do toy service, get toy, and then I will pass the ID. You can see that I don't have this ID, and this is a bit mad at me. So if I use the IntelliSense of the IntelliJ, or if I write it by hand, I can have this annotation, which is path variable, which basically says take the thing that I have in the path, which is named like this. So in this case, ID. If I had here something else random, this random would have been here. So in order for Spring to parse this thing that the user gives me into the thing that I actually need. And we have another problem. Spring created this as a string, and I want it as a long. So I will just have a long here. And now everything is fine. I will be able to retrieve that toy using the ID. How will I be able to retrieve that? I just have to make a get call to localhost 8080 or your domain name. So if you host this somewhere, you will have your domain name there, or the IP address if you don't have a domain name, /API/version1/toy, which is this part. This part is globally prefixed to all the functions that I have below. So API version1 toy will be here. And then I will have another slash, and I will have the toy ID that I want to retrieve. So in this case, if I want to get the toy with the ID 10, I will just have a 10 here. And that would yield me the toy with the ID 10. Okay, let's create the other functions. So I will have a get mapping, which will be at the root of this controller. So that means that it will be accessible at localhost 8080 and then /API/toy, also a get request. And this will yield me all the toys that I have in the database, the function that I've written in the service for getting all the toys, which is the one that's below. So I have a public function which retrieves a list of toys. So I will have the list there. Let me import it. And then I will name it get all toys. The names don't really matter because you won't call them like usual functions. I've told you we'll call them using the API fashion, but they should be named like accordingly so that when you read the code, you know what this will do. And this body will just be a return that will call toy service, get all toys, and I should retrieve on the front end all the toys that I have saved in the database. Okay, now let's have our other mapping. So our post mapping, which is for creating an object, I will have a public toy because, as I've told you, I will create the toy. The database will generate an ID for me, and then I will return the entire object to the caller of the API. So I will name it create toy, and in this case, the user of the API must provide me with the fields of the toy. So if we take a look at the toy object, we have the ID and we have the name, the description, and the image. So I will need those fields in order to save a toy object in the database, because if he provides me with nothing, I don't have a toy object. So in this case, you've seen here, you have the path variable, which is here. This is used for handling variables in the path. But I also have another annotation, which is request body. This will handle the objects or the parsing of the objects that are provided in the body of the request. So for example, when I make a post mapping to this endpoint, and in the body I will have a JSON in the form of a toy object, which will look something like this. So we have the parentheses of the JSON object, we have the name, the name of the toy. I don't know toy names, so I'll just do some random things. Then I have a comma, I have the description, then I have the toy description, whatever, and then I have the image, which is an URL. So the image URL. And for the last one, I don't need to have a comma. So if I put this toy on the left and we take a look at my toy controller and the demo of the JSON, we can see that we have the same field names. So this is mandatory. You need to have this name here. If this would have been named something else, this something else should be reflected here. So if I call this API with the wrong names here, it won't work. I will get a 404 request because because Spring does not know how to map that body to a toy object. And if you can't do that, I can save it in a database and so on. So my request body will contain a toy object. Spring will serialize this for me. So it will take a look at this JSON, and with some magic tricks, it will generate my toy object right here. So if I delete this, now all I have to do is return toy service, create toy, and pass the toy to it. Good. So for updating an object, we've said that we need to use the put mapping. And in the case of our API, because we are overriding the entire object, it will be quite similar with the create toy method. So let's just write it public. Let's actually just copy paste it from here. Okay, in this case, we've said that we will override the entire object, but it would be cleaner to just check field by field and see what we want to object or to update. Or we could have used data transfer object in order to update the fields that we want. You also need to keep in mind that those functions need to have different names. So even if I have different mappings, post mapping, put mapping, those functions need to have different names because after all, this is just a usual Java class with some magic annotation, so to say, from Spring. So let's name it update toy. And all I have to do is return a toy, return a toy service, update toy, and provide the toy that I want to update there. So if we take a look in the service, we have two functions left. We have delete toy and find all. We also need to reflect those in the controller because we will want to actually use them. There is no issue if we don't reflect them in the controller, in the sense that if we leave them like this, it's fine. But you know, if you wrote them here, I guess you want to use them in the controller. So let's write that. So for deleting an object, we said that we want to have a delete mapping, and it will return a void because after I delete an object, unlike creating or updating an object, I don't have anything to return. At best, I can return a boolean which says, hey, I've deleted it successfully, or I haven't found the object and did not delete it, but we'll just keep it simple and assume that the deletion will actually happen. So I will name this delete toy. I need to have the ID. So similar to the get mapping, I will have here the ID value. And I will use the path variable, which will parse me that value into an actual variable. So I will name this ID because I have named it here ID. So you need to have the same name. And I don't need to return anything because this is void. So I can just do toy service, delete toy, and then provide the ID. Okay, so that's pretty much all the code that I have to write. Now all I have to do is pray that it works correctly and test it out in Postman or in Swagger. So I'll give it a run. We'll see if this works. Okay, so if we take a look at this console output, we can see that this is a Spring project because it's Spring here. I also have the version here, which is 3.0.6. We have the package name, the entry point, which is demo application. So if we take a look here, we have this class that contains a main function, which bootstraps my Spring application. So it just says Spring application.run and then this starting point. Good. And now we can see that it connects to the database using this pool of connections because you don't want to connect, to the database on and on and on. So you will want to have one connection or 5 of them or whatever. And then using those 5 connections or this pool of connections, you want to send your requests to the database. Because if you would have needed to connect each time to the database, for example, when creating an object, create a connection, then actually run the query to create the object and retrieving the answer, that would take a long time. So it just is connected to the database and runs the queries through that imaginary tunnel, so to say. Good. So we can see that it has initialized the JPA factory. That is none of our concern so far. And we can see the important part here. We have a Tomcat server, which started on port 8080. So if I want to access that, I just have to say localhost /8080 and then localhost dot 8080, which is the port number. So it would look something like if I open Postman and create a new connection, so a new collection, sorry. And in this new, let's name it demo. and let's create our requests here. Let's add a request, and I have localhost. As I said before, I can see the port number is 880 here. All Spring apps will usually have the port 8080. You can specify otherwise if you take a look in the config of the project. So if you take a look here, you have your database URL, which is this one. You have your database username and password, which are root in this case. I have named them like this because I have also created the database using the same credentials. I have my dialect, which in this case is MySQL dialect, and I have the connection URL. So in this case, I have localhost 3306, which is the port on which SQL runs, which is this container here. We can see the port is right here, 3306. And again, the dialect. Good. So if I take a look in the controller, if I want to access all the toys, I just have to put this path. So if I take a look in Postman and after the server location, I put / and then the path, this should call my get all toys function. You can imagine that it works like actually calling it by hand from another class if it is easier for you, but that's pretty much what actually happens. So if I send this request here, I can see that I get back a JSON which contains all the toys that I have in my database. I have added those toys when I tried the code before the presentation, so that we can have some data in it and make sure that I don't write code that does not work. If I collapse all those objects, we can see the JSON structure. So we have two brackets, which are those, which tells me, hey, I have an array of objects, and the toy objects are those. So if I expand them back. So if we take a look at this JSON, it actually has the same form, so to say, as my toy object. So if I look in my toy object, I have an ID, a name, a description, and an image. And you can see that I have ID, name, description, and image, and the other objects. If we take a look in the database, which I can open on the right here, and give it a refresh, I can see that I have this toy table, which has been automatically created by me from Spring. I have the same column name. So I have this ID, the description, the image, and the name. So basically find all just says, hey, SQL, look at this table, give it all to me. And I just retrieve the entire list. Okay. So if we take a look in the controller, we also have a function that will help us get a single toy. So if I look in the database, let's say that I want the toy with ID 52. So all I have to do is have my server URL, which is localhost 8080. Take a look in the controller and see what mapping do I have for all the functions, which is API/v1/toy, which is added here. And then for retrieving a single toy, I have this mapping, which says, hey, I want an ID. I don't have to actually write that like this here. I have to provide the ID. So I said that I want the toy with ID 52. So instead of that, I will just write 52 here. Now, what will happen when I do this request? Spring will take a look at this path. It will find that this is the controller that I want, API version 1 toy, from this mapping. And the only get mapping that I have, which can consume an ID, is this one. And it will take a look at this 52. It will parse it into this long ID variable. Then it will call this get toy service, which will call find by ID in my repository, which is this one. and that will have the equivalent of a select by ID in my database. And if we run this, hopefully I should get the toy with ID 52, and that happens. You can see that I don't have the square brackets anymore. I just have the object which has this type of brackets with all the keys and the values that I have in the database. If I want to take the toy with ID 1, I do that, and so on. 54 and whatever. Okay. Now, let's take a look at the other methods that we have in our controller. I have this post mapping, which helps me create a toy object. So if I take an object so that I don't have to write it by hand and create a new request and do localhost 8080/API version 1 toy, and in the body of the request, it's a raw type of value and it's a JSON. If I paste that object, I want to create a live created toy, a live description, and the URL would be test/test whatever. This is just a string, so we don't really care about this at this point. One more thing that I need to do compared to the toy demo request, which was a get type of request. I've said that creating an object is usually on a post. So this is a post mapping, so I need to select post here. When I select post here, if I send the request, I will get the toy that was created in the database following the same cycle. So I have this request body. Spring will take a look what is a post mapping that is at this path. This post mapping, which consumes a request body. This request body consumes a toy object. So all of this was parsed in a toy object. So basically the name is live created toy, the description is live created description, and the image is this string right here. The ID is null. So this is automatically created by my database. And we can see that when we get back the object, we have the ID 102. If we take a look in the database and give it a refresh, we have the object with ID 102 created in the database. Good. So now if we go in the get request and we say, hey, give me the toy with ID 102, I will get that toy. Similarly, if I want the entire list of toys, I will see that this is also present here. Good. Now let's say that I don't want the toy with ID 102 present in the database anymore. So I just have to take a look in my controller. I see that I have a delete mapping at this path, which was the path specified on top here. So I will just put a /102. I don't need a request body anymore because it is not consumed. I could just consume a path variable, which is in the URL, which will be 102. And if I send this request, I will get not allowed because I have post here. So remember to change the type of the request. So this will be a delete request because I have the delete mapping here. If I send this request, I will get no response back because I marked this as void. And if I get all the toys again, I will see that I don't have the toy with ID 102 any longer in the database. If I take a look and refresh this, I also don't have it here. Okay, and all we have to do now is update an object in the database. So if I want to update the toy with ID 53, I just go here, I put the put type of request. I don't need the ID here anymore. In the body, I will have this object, and this basically says the object with ID 53 updated to have the following name, description, and image things. So let's put a dash updated on all of them so that we can see if this actually works. So when I actually make this request, I get the ID with the object, the toy with ID 53 and with updated name, description, and images. So if I take a look in my database, I can see that I have them updated. Okay, so that's how to use Postman to test your APIs. If you take a look in the README, you can see that you have a Swagger URL here. If you enter on this Swagger URL, so let's take a browser. If I put it here, I can see that I have a nice page with all the paths and the mappings of my controller. So basically, instead of typing them by hand in my Postman application, I can just do the requests from this UI. So if I want to get all the toys, I just press on this line, which is the type of request on the start and the mapping here. So it's a get for the list of toys, and then I get an example of how this will look like when it is returned. So this helps you if you want to build your front end to know what fields your class should have, because not all the times you want to return in this case, the toy object mapped exactly like this. Maybe you want to only return the description and the image, or without the ID, or so on. And if I press on execute, this will actually make that request. So it's the equivalent of the send button in Postman, and I will retrieve or get back the list of objects that I have. And for the other endpoints, it's the exact same. We have put, post, get, and delete. We've played with them in Postman, so I won't bore you with them again here. You also have the schemas. So if you take a look here, we can see that the toy object, basically here we'll have all the objects that are retrieved or sent to the server. So in this case, we only handle toy objects, so I will have only the toy schema. And if I take a look and unwrap those, I have the types of the parameters. So the name is a string, similar to the toy object here. Name is a string, description is a string, and so on. Okay, I will tell you a few words about the difference between Spring and something like Nest. So for example, if you have a backend that you want to run on lambdas or on cloud functions or on edge functions or so on, you will have to write it in a language that is compatible with such functions, which most of the cases, if you don't want to make a Docker container in that function, which will be extremely slow, you will have to use Python or TypeScript. If you use TypeScript, you can have Nest. So an example of such a thing, so if you want to have Spring as a backend, you will have to have a virtual machine or a Docker container somewhere in the cloud, and then you can access it. If you want to have lambdas, you can just have them written in Nest or Python or so on. So if we want to take a look at how this would look like, let's take a look at one of those projects. And if we take a look in let's take a look in functions, we can see that we have a function here, which if we access by this URL will yield the result of this function. What's the difference between a backend written like this and a backend written in Spring or that runs continuously on a virtual machine? Well, the Spring backend will actually work a bit better, but will scale a bit worse, whereas the backend that you write to use lambdas, that basically can scale infinitely. So when you have a lot of requests, you just start more lambdas and that's it. What's the disadvantage of this approach is that basically if you have something like that, you will have a tough time if you don't have a lot of requests on it. So for example, if we take a look in the browser and run that function and take a look at the network to see how long does it take. If we go on that website, we see that it takes, in this case, it was fresh. So let's try something like that. you will see that it will take a bit more time. This is basically the problem. If your Lambda is cold, then while the server starts the Lambda, it will take quite a lot of time. So if you can see, you have 9 seconds here, which is quite bad. But if I have a nice CDN in front, so if I go on incognito and try the same request again, and I send it, you can see that I have 201 milliseconds, which is really good now. But this was cached on the CDN and the Lambda was now warmed, so it was already running. So basically, this is the difference. If you have an API that you need to have like, really good stability and really good speeds, you will choose something like Spring, which most of the enterprise chooses. But if you want to have, a lot of scalability easily achieved, because you can achieve scalability with microservices in Spring, then you will choose Lambdas if you have a simple project. Okay, so I think that was about it with this demo. You have the code on GitHub if you want to take a look. So yeah, if you have any questions, I can answer them gladly about anything related to backends, or with Spring or with Nest or something else.
Is toy just a convention or an example, or is it like commonly used?
Could you repeat, please?
Is toy, is that just a convention or an example, or is it like actually used?
Toy.
Yeah.
This is just the thing that I want to store in the database. If I want to have something else, I can have a car here. Okay. This is so if you had a toy store, you would store toy objects. If you had, a car dealership, for example, you would store cars. If you can also have multiple objects. If you take a look at, let's take a brief look at the code that was in the past year. So for the news website, if you take a look here in source and then main models, we can see that we have an author, a comment, and the news. So this is the equivalent of our toy. Toy is not a convention; it's just the name of the thing that I want to store in the database. In this case, I store an author, a comment, and a news article, which are linked between them. So the news article holds comments and has an author, which they are mapped like this. So it's not a convention, it's just the name of the object that I want to store. And in this case, in the database, the table name would be news. You can see here the table name is toy, because that's the name of the class. I can also have custom names. So if I annotate this with table, I can say this to be named toy underscore spring or something. If I have a collision in the database, for example, if I have a class named user, usually most of the databases will have already a table named user. So you'll have to name this my user or something that is different. So no, it's not a convention. It's just the name of the object that I chose to demo this flow with. You can have any name here. And then if you have news, of course, your service will be named news service, author service, because I had the author model, and so on. Is it a bit more clear now?
Yeah, thank you.
Okay, no problem. Okay, then if there are no other questions, I will just say a few words about this simple login API. If you take a look at this, this is not what you should actually do, in the sense that this is really insecure. You should use something like either Keycloak if you want to have something that already manages your your users, or you should have something that looks like this, which is a JSON Web Token service, which basically transforms your users into JSON Web Tokens, simply put, and then you'll be able to authenticate them like that. So this is just a demo. Please don't do this in real life. This was just such that we have an example of how to make an API. Okay, then. Yeah, so if you don't have any other questions, that was all of my presentation. If some of you decide to come tomorrow at the GitHub workshop, I'll be waiting.